Okay, so now we will study reaction timer. So as written, reaction timer measures time between turning light on and user pushing button. So let's assume this is a panel, this is a reaction button, and this is some LED on. So it measures the time interval between the turning light on when the light is on and user pushing button. So it can be like, it can be just imitated like a stopwatch. Stopwatch. Let's assume the stopwatch is reset. That will be reset when you start the stopwatch. So it means the user pushes the button, and then the stopwatch will count up. It will count up. And when the user pushes button again, so now this is in first the reset button is pressed, and after the stop button is pressed. So after the stop button is pressed, it will count the time duration when the stopwatch was reset to the time when it was stopped. So it can be used to measure the time interval for the racing. Like if some people are racing, so it means that how fast a person walks or कितना fast वो दौड़ता है. So now let's assume that we are using a 16-bit counter, and let's assume that the clock period is 83.33 nanosecond, and this counter increments after every 6 clock cycles. So it means if it increments after 6 clock cycle, 1 clock cycle, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 1 clock's duration is 83.33 nanosecond, and if you multiply it by 6, so the total resolution is 0.5 microseconds. So the total duration is now 0.5 microsecond. It means that a count of one count will represent a resolution of 0.5 microseconds. So if the count is 0, the time duration will be 0. If the count is 1, the time will be 0.5 microsecond. If the count is 2, the count will be 1 microsecond. If the count is 3, the time duration will be 1.5 microsecond. So what will be the total resolution? The total resolution, since we are using a 16-bit counter or 16-bit timer, it counts from 0 to 65,535. So the maximum value will be 65,535. That will be multiplied by its resolution. So it will be equal to 32,770 microsecond. 32,770 microsecond, and this the maximum range is now. The maximum range is 32.77 millisecond. So now let's assume that the counter is reset. So let's assume the count value is now initial. The count value is 0, and when the user presses the button, and if the count is 30,000, so what will be the time interval? So the time interval is equivalent to count multiplied by resolution. And this particular example, let's assume that when the user presses the button, if it's reset, and again the user presses the button, if the count is 30,000, so the count is 30,000, the resolution is 0.5 microsecond, so this will be equal to 15,000 microsecond. It means that it will be elapsed a duration of 15 millisecond. So we can increase the range. We can increase the range by either increasing the resolution. If we increase the range by increasing the if the resolution is 1 millisecond, so the time will be 30,000, multiplied by 1 millisecond, and this will be equivalent to 30,000 millisecond. It will be equal to 30 seconds. So the total range can be increased either by increasing the resolution, and it can also be increased by using a prescaler, like dividing the clock by 2 or dividing the clock by 4 and so forth, so on. So an example of reaction timer is your stopwatch. So let's assume the stopwatch is 0, 0, this is the odd second, this is second. So it counts from 0, 0, 1, then 0, 2, 0, 3, 0, 4, 0, 5, and so forth, so on. And let's assume the 5 count is 5:49, and user presses the button. It means that it has elapsed a time duration of 5 minutes and 49 seconds. How we can increase the resolution? So what is resolution? How we can increase the range? So the range is equivalent to maximum count multiplied by resolution. And let's assume that we are using an n-bit counter. So the maximum count will be 2 raised to n minus 1 and multiplied by resolution. So how we can increase the range? Either by increasing n. So if n is equal to 8, the maximum count, if n is equal to 8, the maximum count will be 255. If n is 16, the maximum count will be 65,535. If n is 10, the maximum count will be 1023, that is 2 raised to 110 minus 1. So we can increase the range either by increase. So we can increase the range, either by increasing n or either by increasing resolution. So the resolution can be increased by using a larger interval. We can also use prescaler or a clock or slower clock. So another method is, so how we can increase the resolution? Using a slower clock. So let's assume if the clock is 1 megahertz, the resolution will be 1 divided by 1 mega, and that is 1 microsecond. If you are using a clock of 10 megahertz, so this will be 1 divided by 10 m, and this will be resolution of 0.1 microsecond. So if you are using a clock of 1 gigahertz, so the resolution will be 1 nanosecond. So it means faster clock has a smaller resolution, and slower clock has a larger resolution. So now we will study another topic. That is a watchdog timer. So a watchdog timer must reset every X time units. But the common use of it is to detect a failure, and it is also used to detect a failure. And the common use is to self reset. And another use is for timeouts. For example, in ATM machines, I will explain this and elaborate this. So now, what's the definition of the word like timer? It must reset after every X time units. Let's assume that this X is 5 seconds. So it means that the system will be in normal mode. After 5 seconds, this is the reset signal. So after 5 seconds of duration, the system will reset. After again 5 seconds, it will generate a reset signal, and it is used to detect a failure in the system. I will give this as an example of an ATM machine. Let's assume that you are using an ATM machine. You insert your card. Insert your card, you give your password, and you want to accept some money. And actually, if there is a failure in the system, and the ATM asks for some input, and if the system does not receive the input from the user, it will generate a reset signal. So let's assume that the user insert an ATM card, and it's asked for a password. The user gives the password. It asks for the money, and the user has pressed like, and it's asked for the money, but user not has put some input, does not input, and if there is a delay of like some, let's assume for 5 seconds, and the system does not receive an input, it will reset the system and give back the card to the user. So it is used to detect the failure, the failure, and the common system is the common usage is in ATM machines. And it's also used in our desktop application. Let's assume that your computer is hanged and the operating system is not working properly. Maybe then in that case you can reset the system by pressing the reset button. So this reset watchdog counter application to detect failure. If the system is not responding for a specified duration, let's assume that duration is 15 seconds, and the system is not responding, and during this 16, it will automatically reset the system. When it will reset the system, it will be initialized to its known state. For instance, I will give this as an example. Let's assume there is user A, he goes to an ATM machine, he gives the password. Password is correct. ATM asks for money. With how many cash you want to withdraw, and the user does not give the input for 15 seconds. For 15 seconds, it means that the system has not received an input for 15 seconds. So it means that there is some problem in the by the user. So in that particular example, the watchdog timer will send a signal that okay, here may be some failure. It will get a reset signal, it will give back the card to the user and will initialize the system to the known state. Initialize the system to a known state. So in that known state, give back the card to the system, to the user. And if the user does not get the card back and does not put it in the pocket, then it will also wait for another 15 seconds. It does not get it. So the system will grab the ATM card and it will be withheld by the system to avoid some failure. So the watchdog timer is used to detect failure. It generates a signal after a regular interval of time, and if there is no response by the system during that time or by the user during that time, it will initialize the system to a known state. Okay, so this is our lecture for this week. So inshallah, I will give the presentation slides. I will send it on the WhatsApp group. I will also send all the links to the video lecture on YouTube. Okay. I hope you the best of luck. Stay at home and be safe. Thank you very much.